This is question 1 on the quiz, and Scott's going to mark it, so you should see him if you've got any concerns about the marking. The idea in this question was there was a submersible shaped sort of like a torpedo like this with a propeller at the back to drive it either forwards or backwards, and it was operating 15 meters below the surface in Lake Ontario. Lake water comes in here through this tube. This is all lake water in this tube. This is all lake water in this tube, and it's going out through the side of the hull, so it's open to the lake at the side. And there's a manometer connected in between, as shown. Now this manometer is full of Miriam 190 blue fluid, which is an actual manometer fluid that's almost twice the density of water. And it doesn't mix with water, so these interfaces stay clear. Dimensions as shown. And the first question was, which direction is the submersible moving? Indicate with an arrow. And how can you tell? Well, looking at this, looking at the manometer, the pressure is higher on this side than it is on that side. That means that the pressure here is higher than the pressure along the side of the hull. That means this has to be a stagnation point. The submersible is moving this way through the water. That's the direction. And it's because the manometer shows a higher pressure here, so there's a stagnation point on the front. So that's the first question. What is the speed of the submersible if the manometer height h is 1.4 meters? So if that height is 1.4 meters, what's the speed of the submersible? Well, first off, we can apply statics between this location and this location, between points 1 and 2, through the manometer to figure out what the pressure difference is. So P1 will be equal to P2 plus whatever increase in pressure due to the manometer fluid there, that's the rho manometer GH there, minus whatever decrease in pressure through the water here, that's minus rho H2O GH there from statics. And these bends and drops in the pipe make no difference because for every meter it goes up in the water, it goes back down again. Likewise here, up and back down again. So the only element important there for figuring out the pressure difference is that height. And if we follow that through, we wind up with 12,361 pascals. Now from Bernoulli's equation, the stagnation pressure will depend on what the velocity is. So we wind up with the delta P, the difference in pressure between here and a location out in front, which will be the same as the pressure on the side here. That delta P over rho G equal to V squared over 2G, because here V is 0. Rearranging, V square root of 2 times delta P over rho, 4.97 meters per second. So, having made those straightforward applications, the question then was, how would the result change if the rear tube was connected to the top of the hull instead of the side? So that's saying, if instead of coming out of the side at the same elevation here as the front, what if it came out the top? The answer is, if it came out the top, the delta H for the point would show up as a larger delta P in both the static equation, that is, the difference between P1 and P2 would be larger from the static calculation, and delta H would also show up as an elevation change in Bernoulli and cancel out. So here's what we'd wind up in our analysis instead. P1 equal to P2 plus rho H2O G times the radius of the hull. That's the increase in pressure from here down to here, plus the changes in elevation through the manometer that we had before. And then, when we apply Bernoulli's equation, we'd wind up with delta P over rho G equal to V squared over 2G plus rho H2O G R. That's the increase in elevation going from point 1 to a point 2 that would be up here on top of the hull. That and that will cancel each other out, and the end result is no effect. And finally, if the submersible was operating at 30 meters depth, all of the pressures would be higher. They would all be higher by an equal amount, but all the delta P's and the density, because water is incompressible, are going to be the same. So there'll be no effect on our calculations, no effect on the performance.